In this video, I have focused on the Pauli exclusion principle, and this is the second part of the semiconductor physics video. So in the first video I have just discussed about the classification of solids, and then after I have discussed that what are the similarities and differences in aluminum and silicones on the basis of atomic number, atomic density, mass density, binding energy, temperature, resistivity, all these things. Then after I have discussed about the quantum numbers, which are important to understand the concept of energy bands in solids. But before we go into the details to understand the energy bands in solid, it is important that we understand clearly the four quantum numbers. So here in this particular slides I have just discussed about the Pauli exclusion principle. What basically Pauli exclusion principle states? It basically defines that no two electrons may have same four quantum numbers. Right? What is it means basically? You have seen earlier कि जो एटम है, एटम के पास फोर क्वांटम नंबर्स हैं और those four quantum numbers are signified by the letters N, L, Ml and Ms. So I have considered, suppose, a simple example of neon in which you know that there are 10 electrons. Or an example of calcium, calcium have atomic number 20, it means there are 20 electrons. You know that all the electrons have same mass, same charge, right? So all these electrons are similar, identical particles. We says कि these electrons are identical particle. Question is that in an atom, how one can distinguish among the electrons, their characteristics, कि आप किसी एटम के अंदर 20 इलेक्ट्रॉन्स हैं या 10 इलेक्ट्रॉन्स हैं, how they are different from each other? Is there any way to make the differentiation between them? Yes, the answer is on the basis of quantum numbers, one can make the distinguishness among the 10 electrons, 20 electrons or 30 electrons. Right? So these four quantum numbers are important because of that point. These N, L, M, L and Ms, these four quantum numbers are important in atomic physics. Right? So the purpose of this video lecture is to explain the Pauli exclusion principle, and with the help of four quantum numbers to define that how these electrons are different from one another. कि ये जो 10 इलेक्ट्रॉन है या 20 इलेक्ट्रॉन्स हैं एक दूसरे से किस तरीके से डिफरेंट हैं फ्रॉम द कैरेक्टरिस्टिक्स पॉइंट ऑफ व्यू. राइट? So this is the second part of the semiconductor physics, which is based on the Pauli exclusion principle. Right? Now you have the basic idea of N, principal quantum number, L orbital quantum number, Ml magnetic quantum number, Ms is the spin quantum number. Right? So from the beginning, for N is equal to 1, that will be which cell? K cell. Right? So what will be the value of L? You know that vary from 0 to n minus 1. If you know the N principal quantum number, you can define the orbital quantum number. Right? So here N is equal to 1, so L will be equal to what? That will be equal to 0. Right? So it means L is equal to 0 represent to the which orbital? S orbital. So now there how many orbitals are in one cell? N is equal to 1 cell, that is K cell. In the first cell, how many orbitals are there? Only one orbital, that is the s orbital only, and this s orbital signifies by the orbital quantum number, and that s orbital is defined by the subcell into the k cell. So 1s is the subcell. So how many number of the electrons will be into 1s subcell? Now the point is, for that we will discuss about the ml. This is the third quantum number. So ml will be equal to 0. How? Because for a given value of L, ml vary from minus L to plus L. Here L is equal to 0, so because of that ml have only one value, that is 0. And now the fourth quantum number, that is the spin quantum number. So now in this s orbital, we know two electrons can exist. So one electron will be with spin up, or second electron will be spin down. So the point is, the question, how many electrons can exist in one s subcell? We know that two electrons can exist in s orbital. So how does all these four quantum numbers will be same or different for these two electrons in a orbital, in a subcell? This is the question. क्या चार क्वांटम नंबर सेम होगी या डिफरेंट होगी फॉर दीज टू इलेक्ट्रॉन्स इन ए ऑर्बिटल? इन ए रूम only two electron can exist, but what about the quantum numbers? Does they will be same or they will be different? See here, for n is equal to 1 case I have select. For that L is equal to 0, ml is equal to 0, ms is equal to plus 1 by 2. First possibility for the first electron. Right? The concept is there can be two electrons. So one is with spin up and second is with spin down. These three quantum numbers are same for both the electrons, but fourth quantum number is different. So this is the result of the Pauli exclusion principle. Pauli exclusion principle says that no two electrons may have the same four quantum numbers in a particular energy state. So in L is equal to 0 subcell, how many number of electrons can exist? 2 electrons. And what about the quantum numbers? For the first electron, these are the quantum numbers. For the second electron, these are the quantum numbers. And you can see here that these are different because of the spin quantum number. So this is the verification of the Pauli exclusion principle. Right. So now you can take one more example. For n is equal to 2, that is basically L cell in an atom. If n is equal to 2, you know how many orbital quantum number will be? L is equal to 0 and 1. L is equal to 0 signifies the s orbital. L is equal to 1 signifies the p orbital. So this is the second cell. So the subcell will be 2s and 2p. So now you know that how many number of electrons can exist in s orbital? 2 electrons. How many electrons can exist into the p orbital? 6 electrons. So total number of electrons in second cell will be 2 plus 6 will be equal to 8. So 8 electron can exist into the L cell. How to verify it? For the verification of it and for the verification of the Pauli exclusion principle, let us see the further quantum numbers. Right, L is equal to 0, that is s orbital. ml will be equal to 0 and ms will be plus 1 by 2 and minus 1 by 2. There are two possibilities of two electrons in s orbital. One is with spin up and second is with spin down. So there are how many electrons correspond? L is equal to 0 orbital, 2 electrons. Right, you have seen here that calculation. Now for L is equal to 1, that is basically p cell. Now the third quantum number is the magnetic quantum number ml. ml varies from -1 to +1. Why? Because L is equal to 1 here, and ml varies from -L to +L. So -1, 0, +1. So for each quantum number, magnetic quantum number, there are two possibilities of the spin quantum number. One is spin up and second is spin down. For spin up you are writing plus, for spin down you are writing minus. Right, so +1/2 and -1/2 for this quantum number, and similarly for 0 and similarly for this +1. Right, so L is equal to 1, ml is equal to 3 values, and corresponding to each value of ml there are two spin quantum number. One is with spin up and second is with spin down. So total number are 6. How you can define this? That defined through this particular table. N is equal to 2, that is the second cell. L is equal to 1, that is the p orbital, right? Because I have considered right now the p orbital. So ml values vary from -1, 0, +1. So for nl will be same because n is the second cell, L is the p orbital. These two quantum numbers are same, and for each value of L, ml is vary from -1 to +1. So you can write it -1, 0, +1. So this is the column of ml, and for each value of ml there are two values of ms. One is with spin up and second is with spin down. So you can see here two electrons, right? One is with quantum number 2, 1, -1, +1/2, and second electron is n is equal to 2, L is equal to 1, ml is equal to -1, and ms is equal to -2. And similarly two electrons with this quantum number, n is equal to 2, L is equal to 1, 0, +1/2, and fourth electron -1/2. Fifth electron 2, 1, +1, +1/2. Sixth electron 2, 1, +1, -1/2. So by this way, if you add all these four quantum numbers that represent to the individual electrons, so there will be total 6 electrons. This is a little bit, here you can see, complex, right? Because I am just explaining the quantum numbers for a given value of L, right? You have seen here L is equal to 1, so ml की कितनी values होंगी? -1, 0 and +1, right? They are written here, -1, 0, +1. So up to here n, L, ml, how many quantum numbers are these? 3. So 2, 1, -1, 2, 1, 0, 2, 1, +1. These are 3. Right. Now what about the spin quantum number? You know there are two spin quantum number. One is with spin up and second is with spin down. So one possibility is 2, 1, -1, +1/2. Second possibility 2, 1, -1, -1/2. Right? So if you see only first two row, you can understand very easily that with the help of these quantum numbers, spin up and spin down quantum numbers. 1 signifies the first n2, 1, -1, +1/2, 1 electron state, and for the second electron, that is 2, 1, -1, -1/2. And similarly I have explained here about two rows, right? So by this way you can see here in L is equal to 1, that represent the p orbital, 6 electrons. So by this way you can see 2 electron plus 6 electron, total number of electrons are 8. Now if you have this idea, right, and this idea is clear about the quantum number, I can extend it for the n is equal to 3 and n is equal to 4 also. But in the next section n is equal to 3 will be clear if you have this idea, if you have understand this idea clearly, right? I hope I have made this clear about the quantum numbers n, l, ml and ms, right? So above you have seen here that n is equal to 1, l is equal to 0, ml is equal to 0. There is only one value of ml, but you can see here plus 1 by 2 and minus 1 by 2. So for a given value of ml, there are two possibilities of the electrons. One is with the spin up and second is with the spin down, right? So this is the point. आपकी एक ml वैल्यू के लिए दो पॉसिबिलिटी हैं इलेक्ट्रॉन स्पिन क्वांटम नंबर की, एक स्पिन अप और एक स्पिन डाउन. So here I am writing -1. So there are two possibility. One is with the spin up and second is with the spin down. So by this way, with the help of spin quantum number, you can categorize the electron with the help of these quantum numbers. Similarly, ml is equal to 0. So there are two possibility. One is with the spin up and second is with the spin down. So the quantum numbers will be 2, 1, 0 plus 1 by 2. And the fourth electron, that will be 2, 1, 0 minus 1 by 2. So this is the idea for the four quantum numbers, and according to the Pauli exclusion principle, for the two electrons all the four quantum numbers cannot be same. चार क्वांटम नंबर जो गिवन है वो किसी भी टू इलेक्ट्रॉन्स के लिए सेम नहीं हो सकती. या तो L डिफरेंट होगा, ML डिफरेंट होगा, MS डिफरेंट होगा, right? So this is the idea. And similarly I have discussed here about n is equal to 3, that is represented by the capital M cell, and you know that there are total 18 electrons. So if you know n is equal to 3, you can find out the value of L, that is the orbital quantum number, because L vary from 0 to n minus 1. So maximum value of L will be n minus 1. It starts from 0. 0 represent to the s orbital, 1 represent to the p orbital, 2 represent the d orbitals, right? So I am considering, so there are 3 orbitals. And you have the idea that each orbitals have their own capacity to accumulate the electrons, right? S orbital can accommodate 2 electrons, p orbitals can accommodate 6 electrons, d orbitals can accommodate only 10 electrons. So total number of electrons for this particular cell, where you have seen 3 orbitals s, p, d. So there will be 18 electrons. You can see here that s orbital have 2 electron, p orbital 6, d orbital 10. So total number of electrons in third subcells are 18. So you can see, you can check here Pauli exclusion principle. You can check the total number of the electrons in orbital. So this is the point only, and by the help of these quantum numbers one can understand all these things, and that can make distinguishness among the identical particle, as shown here. That in quantum mechanics, if you have some idea of the quantum mechanics, where a particle is represented by a wave function, that wave function basically have the 4 quantum numbers n, l, ml and ms. That wave function basically like a name of a person, like a name of a student in the classroom, right? So I can take a best example here. If suppose you are sitting in a classroom and total student in a classroom are 40, right? And there is a teacher also, to total 41. So the point is, all the students are identical, they are human beings. So how one can make distinguishness among them, right? Or if you see a similar kind of animals outside, so how you can make basically distinguishness among them? There are some characteristics like a student, the name, the class, the section, the living place, where he lives, right? What is the home address? So there are so many parameters to make the distinguishness among the students. Similarly, in atom, how one can make the distinguishness, that basically come from the quantum numbers, these quantum numbers n, l, ml, ms, right? So this was the idea of quantum numbers and about the Pauli exclusion principle. If you have any question, any doubt, you can message me below this video. Thanks for watching this video.